So Ethereum was the first general purpose blockchain. We had Bitcoin, which allows us to send value from one wallet to another, but Ethereum was the first blockchain that allows you to execute whatever logic you want in a decentralized way on different nodes. You can write smart contracts, and the blockchain will preserve the state and change it based on transactions, right? But in blockchains, and specifically in Ethereum, we also have this famous trilemma between scalability, decentralization, and security. So if you want to have more scalability, you need to give up a bit on security or on decentralization. And if you want your blockchain to be more secure, then it's probably going to be a bit less decentralized or scalable. So this is the famous blockchain trilemma, and we have this problem actually in Ethereum. So in Ethereum, for example, when there is a very famous NFT collection being minted, there is a lot of demand to get into the block, to get the airdrop or to get this new NFT. So people are willing to pay a lot of fees in terms of gas for transactions. And that's when gas prices are going to the moon. And if you want to just transfer ERC20 tokens or swap tokens, it costs a lot of money in terms of transaction fees, which means that Ethereum is not that scalable. Well, there are different ways to scale Ethereum, and one of them is layer 2s. So what is the difference between layer 1 to a layer 2 blockchain? First of all, you're probably familiar with layer 1 blockchains. Ethereum, for example, is the most famous layer 1 blockchains. Here you can see other EVM compatible chains, blockchains that are compatible with Ethereum virtual machines, and are also layer 1, like Binance Smart Chain, Phantom, Avalanche, Polygon. These are all layer 1 blockchain based on EVM. We also have Rust-based blockchains, layer 1 blockchains like Solana, Polkadot, Near, Metaverse X, etc. We have also Move ecosystem. All of these are ecosystem: EVM, Rust, Move, Cosmos SDK, and Haskell. And in this ecosystem, we have different type of layer 1 blockchains. So in Move language, we have Aptos and Sui. In Cosmos SDK, we have a lot of blockchains layer 1 blockchains that are built on Cosmos blockchain. And actually Cosmos is considered layer 0 also. Some people call it layer 0 because it's an infrastructure, an SDK that allows building layer 1 blockchains on top of it. And we have Celestia, Lava, Osmosis, Terra, which is already dead chain, Injective, Chronos, Torchain, and many more blockchains that are deployed on Cosmos. And we have Haskell, Cardano. I would also put here the dead emoji because it's pretty dead blockchain. And by the way, these are the top 5 layer 1 blockchain protocols. We have here Solana, Ethereum, Avalanche, BNC, and I have no idea what is this one, maybe Cardano, but I'm not sure. Well, these are all layer 1 blockchains, and one of the ways to scale the scalability, the transaction throughput, how many transactions we can process per second in layer 1 blockchains are layer 2 blockchains. So layer 2 blockchains are built on top of layer 1 blockchains. That's why they're called layer 2, because it's another layer on top of the first layer. Now, most of the layer 2s are built on top of the Ethereum blockchain, and basically we are moving the computation, the expensive computation and the storage of data from the layer 1 blockchain, from the Ethereum blockchain, to other blockchains that are built on top of Ethereum. That's the idea of layer 2s. And that's how we can achieve scalability and speed, because these layer 2 blockchains are much faster than Ethereum. They are much cheaper in terms of transaction fees, but we still preserve the layer 1 security. Because these layer 2s, it's like independent blockchains that are much faster, much lower than fees, but every once in a while, we aggregate all the transactions and we submit them into the layer 1 blockchain to preserve the security of the consensus of the layer 1 blockchain. And that's exactly what happens on layer 2s that are built on top of Ethereum. You can sign transaction, you can send transaction, you can use the blockchain, you use DeFi, you use NFTs, and then the blockchain itself aggregates all the recent transactions. You can imagine that it puts it into a smaller pack, much lighter pack, and then pushes it all at once to Ethereum blockchain. Now we have different types of layer 2 blockchains, and every type is trying to achieve the same purpose but in a different way. Here you can see all the available scaling solutions that we have for layer 2s on top of Ethereum. So we have different types. It's categorized by types. We have ZK rollups, zero knowledge rollups. We have optimistic rollups. We have sidechains, Validium, hybrid solutions, state channels, plasma. Don't be overwhelmed with the names. Basically, all of them, it's just different methods and different techniques to achieve what we just described here, to have better scalability, faster transactions, cheaper transactions, but meanwhile preserving the security and the reliability of the consensus layer of the layer 1 blockchain, which is Ethereum. And you can see how they are categorized. In ZK rollups, we have Starkware, Starknet, ZK Sync, Loopring, Hermes, Aztec, Matter and optimistic rollups. We have Optimism, also Arbitrum, and many more examples. We're not gonna go through every example. If you want, you can read more about any of these blockchains if you wanna dive deeper, because our focus is on ZK rollups, on Starkware and Starknet. This is our layer 2 of this course. So this is exactly how layer 2 blockchains work. Like I described before, we compress and aggregate a lot of transactions that are being submitted and executed on top of the layer 2, and we submit them, all of them, to layer 1 to basically update the state on the layer 1 blockchain to achieve the security of the layer 1.